in this experiment, zinc react with the dilute sulfuric acid. The equation is zinc plus H2SO4 gives H2 plus ZnSO4. Milk of magnesia. Milk of magnesia is magnesia hydroxide. The pH value of milk of magnesia is 10. NaCl containing Na plus and Cl minus ion. H2O containing H plus and OH minus ion. It's decomposed to form NaOH. Today we are going to discuss our new chapter, acid, bases and salt. What is acids and bases? Yes, acids with a sour taste and bases are the substance with a bitter taste. Acids are the substance with the sour taste and bases are the substance with a bitter taste. Very good. Then see this. Here different solutions have been taken in 3 beakers. Beaker 1, beaker 2 and beaker 3. Different solutions have been taken in 3 beakers. In each of them, a blue litmus paper and a red litmus paper have been dipped. Observe the color change. Observe the color change of the litmus paper. Here, in the first beaker, the blue litmus paper changed to red. First beaker, the blue colored litmus paper changes to red color. In the second beaker, there is nothing special here. Blue litmus paper and red litmus paper are present. There is nothing changed. In the last beaker, here the red color litmus paper changes to blue color. Red color litmus paper changes to blue color. First and last. First beaker, blue color litmus paper changed to red color, but in the last beaker, the red color litmus paper changes to blue color. That means in the first solution is an acidic solution. This one is an acidic solution. Acidic solution. Second one is a neutral solution. And the last one is a basic solution. In acidic solution, the blue colored litmus paper turns red color. In neutral solution, there is no color change. And in basic solution turns the red colored litmus paper to blue. Okay. So acids are the substance with the sour taste. And it changed blue colored litmus paper to red color. Acid are the substance with sour taste and acid are the substance with changed blue color litmus paper to red color. Example, lemon juice, vinegar. Then base are the substance with bitter taste. And here the red color litmus paper changed to blue color. Bases change the red color litmus paper to blue color. Litmus paper color change. In the basic medium, the red color litmus paper changed to blue color. In an acidic medium, the blue colored litmus paper changed to red color. Okay, is it clear? Example for basic solution is soap, baking soda, etc. Soap, baking soda, and paste also and also a base. Acids are the substance with the sour taste and it changed blue litmus paper to blue colored litmus paper to red color. Example, lemon juice and vinegar. And bases are the substance with a bitter taste. It changed red litmus to blue. Example, soap, baking soda, paste, etc. Then indicators. What is indicator? Indicators are the substance that show different colors in acidic and basic solution. Different colors. Indicators are the substance that show different colors in acidic and basic solution. Filter paper, it is an indicator because in blue colored litmus paper changed to red in acidic medium. So litmus paper is an example of indicator. And then indicator classified into three types: natural indicator, synthetic indicator, and olfactory indicators. Natural indicators, synthetic indicators, and olfactory indicators. Natural indicators are litmus, turmeric, colored flower petals like hibiscus. Then synthetic indicators are methyl orange and phenolphthalein. Methyl orange and phenolphthalein are synthetic indicators. Methyl orange and phenolphthalein. Phenolphthalein is colorless in acidic solution. Phenolphthalein is colorless in acidic solution. Colorless in acidic solution. And pink color in basic solution. Pink color in basic solution. Colorless in acidic solution and pink color in basic solution. In methyl orange, orange red color in acidic solution. Acidic solution. And yellow color in basic solution. Okay, synthetic indicators are methyl orange and phenolphthalein. Phenolphthalein colorless in acidic solution and pink color in basic solution. In the case of methyl orange, red color in acidic solution and yellow color in basic solution. And next one is olfactory indicators. These substance whose smell changes when mixed with the acidic or basic solution. These substances whose smell changes when mixed with the acidic or basic solutions like vanilla, onion, clove, etc. Then look at this activity. Activity 2.1. Collect the following solutions from the science laboratory: hydrochloric acid, sulfuric acid, nitric acid, acetic acid, sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide, and ammonium hydroxide. Put a drop of each of the above solutions on a watch glass one by one and test with a drop of the indicators shown in table 2.1. What change in color did you observe with the red litmus, blue litmus, phenolphthalein, and methyl orange solution for each of the solution taken? Tabulate your observation in table 1. We know that acids are the substance which turn blue litmus paper to red. So all acids turn blue colored litmus paper to red color. All acids change blue color litmus paper to red color. See our first experiment. Acid are the substance change blue color litmus paper to red color. Blue color litmus paper changed to red color. Then base are the substance. It changed red color filter paper to blue color. Sorry, filter paper. It's litmus paper. Red color litmus paper to blue color litmus paper. Then next indicator is phenolphthalein. We know that phenolphthalein in acidic medium. Phenolphthalein in acidic medium. It is colorless. And phenolphthalein in basic medium. It's pink in color. Phenolphthalein in basic medium, pink in color. And methyl orange. Next indicator is methyl orange. Methyl orange in acidic medium. Acidic medium is orange red color. And basic medium, it's yellow color. Okay. Then fill the table. HCl, hydrochloric acid. HCl is hydrochloric acid. It's an acid. Acid turns blue litmus paper to red. So here red litmus solution, no change. HCl turns blue litmus solution to red. And phenolphthalein solution in acidic medium. Phenolphthalein in acidic medium. What is it? Yes, colorless in acidic medium. Colorless in acidic medium. And methyl orange. Methyl orange in acidic medium. Yes, orange red color. It's orange red color. Okay, because HCl is an acid. HCl is an acid. So red litmus paper, red litmus solution, there is no change. But in blue litmus solution, change to red color. In the phenolphthalein solution, it's colorless. Methyl orange to red color. Because HCl is an acid. Sulfuric acid, H2SO4. H2SO4, it is also an acid. So, red litmus solution, no change. Blue litmus solution turns to red. Phenolphthalein solution, colorless. Methyl orange solution, orange red color. Nitric acid, acetic acid, both are acids. So, they are red litmus solution. There is no change. And in the case of blue litmus solution, it turns red. And in phenolphthalein solution, colorless, and methyl orange solution, orange red color. And then sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide and ammonium hydroxide are bases. So it turns red litmus paper to blue litmus paper. Bases. Bases are the substance which turn red litmus paper or red litmus solution to blue. And blue litmus solution, no change. Blue litmus solution, no change. Phenolphthalein. Pink color in basic medium. Pink color in basic medium. And methyl orange. Methyl orange solution. Methyl orange solution. Yellow color in basic medium. Yellow color in basic medium. Sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide and ammonium hydroxide are bases. Okay. An acidic solution is changed blue litmus paper or blue litmus solution to red color. Basic solution change red litmus paper or red litmus solution to blue color. Phenolphthalein in acidic medium is colorless and in basic medium is pink in color. Methyl orange in acidic medium is orange red color and in basic media it's yellow color. Okay. Next topic is chemical properties. Chemical properties of acids and bases. Chemical properties. First chemical property is reaction with the metals. Reaction with the metals. Acids and base react with the metals. We know that metals react with the acids to liberate hydrogen gas. Here zinc granules, zinc, Zn, react with the dilute sulfuric acid, H2SO4. React with the dilute sulfuric acid. It liberates hydrogen gas. It liberates hydrogen gas. And the hydrogen, burning of hydrogen gas with a pop sound. Write down the equation. Zinc react with the sulfuric acid, H2SO4. Zinc react with the sulfuric acid, H2SO4, to form hydrogen gas and a salt. That salt is zinc sulfate, ZnSO4, zinc sulfate. So zinc react with the sulfuric acid, it liberates hydrogen gas and also form zinc sulfate. Generally, acids react with any metal to form salt and liberate hydrogen gas. Acids react with any metal. Any acid react with any metal to form a salt and liberate hydrogen gas. In this experiment, zinc react with the dilute sulfuric acid. The equation is zinc plus H2SO4 gives H2 plus ZnSO4. Another example, zinc react with the HCl. Zinc is a metal and HCl is an acid. So metal react with the acid, it liberates hydrogen gas. So Zn plus HCl gives H2. It liberates hydrogen gas H2 and to form a salt. Here zinc chloride. Zinc chloride is formed. Zn react with the HCl to form zinc chloride and hydrogen. Okay, is it clear? Acid react with the metals to form salt and hydrogen gas. Then next one, base. Base react with the metals. Similarly, base react with the metals to form salt and hydrogen gas. But in the case of bases, only reactive metals react with the base. Only reactive metals. Some metals are highly reactive, but some ones are least reactive. Sodium, potassium, etc. are highly reactive metals, but gold, copper, etc. are less reactive metals. Here, reactive metals react with the base to form salt and hydrogen gas. For example, NaOH react with the zinc. NaOH react with the zinc to form Na2ZnO2. Na2ZnO2. It's a salt of NaOH and zinc and it liberates hydrogen gas. So, acid and bases react with the metals, it liberates hydrogen gas and form a salt. Okay, acid and bases. Both acid and bases react with the metals and liberate hydrogen gas and to form a salt. Next one is reaction with the metal carbonates and hydrogen carbonates. Metal carbonates and hydrogen carbonate. Here, sodium carbonate. The formula of sodium carbonate is Na2CO3. Sodium carbonates react with the hydrochloric acid HCl. Sodium carbonate react with the hydrochloric acid HCl. It liberates a gas. The gas is carbon dioxide. Sodium carbonate. Any metal carbonate react with any acid, it liberates carbon dioxide gas. Sodium carbonate, it's a metal carbonate and it's react with the HCl. HCl is an acid. So any metal carbonate react with the acid to liberate carbon dioxide gas. Here in this reaction, it emit carbon dioxide gas and the carbon dioxide gas is passed through lime water. Carbon dioxide gas is passed through lime water. Observe the result. The lime water turns milky. Carbon dioxide passes through lime water. The lime water turns milky. Okay. Acid plus metal carbonates or metal hydrogen carbonate react to form salt, carbon dioxide and water. Acids react with the metal carbonates or metal bicarbonate. Metal carbonate is CO3. CO3 2 minus. Bicarbonate or hydrogen carbonate. Another name is bicarbonate. Metal bicarbonate or metal hydrogen carbonate. The formula of hydrogen carbonate or bicarbonate is HCO3 minus. Acid react with the metal carbonate or metal bicarbonate to form salt and carbon dioxide. Salt, carbon dioxide and water. Na2CO3, it's a metal carbonate. Na2CO3 is sodium carbonate. It reacts with the HCl. HCl is an acid to produce carbon dioxide gas, CO2 and water and a salt. Salt is NaCl. Products are NaCl, carbon dioxide and water. CO3 changed to CO2 and hydrogen atom combine with the oxygen to form water, and sodium and chlorine combine to form a salt, NaCl. Next example is sodium bicarbonate. NaCO3 is sodium bicarbonate. NaCO3, sodium bicarbonate. It's a metal bicarbonate because sodium is a metal. So NaCO3 is metal bicarbonate. It reacts with acid like HCl to form. Here also it eliminates carbon dioxide gas and to form water H2O and a salt. Salt is NaCl. NaCl. Okay. Acids react with the metal carbonates or metal hydrogen carbonate. It liberates carbon dioxide gas. Carbon dioxide gas. Okay. Then next test for carbon dioxide. How to test the how to identify the formation of carbon dioxide. Yes, carbon dioxide gas is passed through lime water. The lime water turns milky. Lime water is calcium hydroxide. Carbon dioxide gas is passes through lime water. Lime water is chemically calcium hydroxide. Suddenly, the lime water turns milky because here the formation of calcium carbonate. Calcium hydroxide react with the carbon dioxide to form calcium carbonate. Calcium carbonate is a white precipitate because the lime water turns milky. Carbon dioxide gas passes through lime water. The lime water turns milky because the formation of calcium carbonate. Calcium carbonate is a white colored precipitate. Lime water is chemically calcium hydroxide. Calcium hydroxide react with the carbon dioxide CO2 to form CaCO3, calcium carbonate and water. Then on passing excess of carbon dioxide, then this carbon dioxide react with the calcium carbonate and water to form calcium bicarbonate. It is soluble in water. If we pass excess of carbon dioxide on lime water, excess of carbon dioxide is passing through lime water, then the calcium carbonate and water mixture react with the excess of carbon dioxide and to form a soluble calcium bicarbonate. Calcium bicarbonate is soluble in water, but calcium carbonate is insoluble in water. Calcium carbonate, it is insoluble in water, and calcium bicarbonate is soluble in water. So, carbon dioxide passed through lime water turns milky because the formation of calcium carbonate. Calcium carbonate is insoluble in water, but excess of carbon dioxide is passing. The carbon dioxide react with the product calcium carbonate and water to form calcium bicarbonate. Calcium bicarbonate is soluble in water. Next one is neutralization reaction. Neutral. That means acids and bases react. To form salt and water. Suppose NaOH. NaOH is a base and HCl is an acid. It reacts to form water. OH plus H to form water. H2O, and Na plus reacts Cl minus ion to form NaCl. Suppose KOH. It's a base. KOH, potassium hydroxide. It's a base. It react with sulfuric acid. H2SO4. Suppose KOH react with sulfuric acid. H2SO4. What are the products? KOH is a base and sulfuric acid is an acid. Products are corresponding salt and water. OH and H combine to form H2O plus potassium and sulfate combine to form potassium sulfate, K2SO4. Okay. Suppose KOH react with HCl. KOH react with HCl. KOH is a base and HCl is an acid. To form acid and base react to form water and a salt H2O, and remaining substance K plus and Cl minus. They combine to form KCl. KCl plus H2O. Acid and bases, generally acid and bases react to form corresponding salt and water. Next one, reaction of metallic oxide with the acid. Reaction of metallic oxide with the acid. Metallic oxide, that means metal connected to oxygen. That type of compound is called metallic oxide. Aluminium oxide, potassium oxide, sodium oxide are metallic oxides. Zinc oxide also a metallic oxide. Then metallic oxide react with the acid. It also produces corresponding salt and water. Metallic oxide react with the acid is produce salt and water. Do this activity. Take a small amount of copper oxide in a beaker and add dilute hydrochloric acid slowly while stirring. Note the color of the solution. What has happened to the copper oxide? Copper oxide. Copper is a metal. So copper oxide is metal oxide. Is react with the dilute HCl, dilute hydrochloric acid. Hydrochloric acid is an acid. So metallic oxide, we know that metallic oxide react with acid to form corresponding salt and water. Corresponding salt and water. Copper oxide, CuO, it react with the dilute HCl to form corresponding salt and water. Water H2O, and remaining cation is Cu plus and anion is Cl minus. So it will form CuCl2, and water CuCl2 is the salt. Copper oxide react with HCl to form CuCl2 and H2O. Copper oxide changed to a blue colored solution because CuCl2 plus water in aqueous CuCl2 is a blue colored solution. All metallic oxides are basic in nature. That's why it reacts with the acid. HCl is an acid. So a base react with the acid to form salt and water. Here, metal oxide react with the acid to form corresponding salt and water. We know that generally acids react with the base to form salt and water. Here, metal oxide is also react with acid to form salt and water. That means metal oxides are basic in nature. Metal oxides are basic in nature. Note it. Metal oxides are basic in nature. That means metallic oxides are basic oxide. Metallic oxide is also known as basic oxides. Metallic oxides are basic oxides because it react with the acid. Metallic oxides react with the acids and to produce salt and water. Generally, acid react with base to produce salt and water. Here, metallic oxide react with acid to produce salt and water. That means metallic oxides are basic in nature. These are basic oxides. Next one, reaction of non-metallic oxides with bases. Reaction of non-metallic oxides with bases. Previous one is reaction of metallic oxide with the acids. Metallic oxide with acid. Next one is reaction of non-metallic oxides. That non-metallic oxides are oxygen connected with the non-metals. Oxygen connected with the non-metals with the bases. Then the general formula is non-metallic oxides react with the base to form salt and water. Non-metal oxides react with the base to form salt and water. That means the non-metal oxide is acidic or basic. Yes, very good. These are acidic. Non-metallic oxides are acidic in nature because they react with a base to form corresponding salt and water. For example, calcium hydroxide react with carbon dioxide. Carbon dioxide is a non-metallic oxide. Carbon dioxide is a non-metallic oxide. Is react with the calcium hydroxide. Calcium hydroxide is a base to form water and corresponding salt. Corresponding salt is calcium carbonate, CaCO3, and to form water, calcium carbonate and water. Non-metallic oxides are acidic in nature. It's also known as acidic oxide. And metallic oxides. Metallic oxides are basic in nature. Metallic oxides are basic in nature and non-metallic oxides are acidic in nature. Note down. Metallic oxides are basic in nature and non-metallic oxides are acidic in nature. Carbon dioxide gas, it's acidic in nature. It's an acidic oxide. Carbon dioxide is an acidic oxide. But zinc oxide is an basic, or copper oxide, it is an basic oxide. Zinc oxide is a basic oxide. Why? Because zinc oxide reacts with the HCl to form salt and water. Zinc oxide is a basic oxide, or zinc or copper oxide is a basic oxide, and carbon dioxide is an acidic oxide. Generally, non-metallic oxides are acidic in nature and metallic oxides are basic in nature. Okay. Then next topic, formation of ions in aqueous solution. Formation of ions in aqueous solution. First one, acids in water. Acids diluted in water. Acids diluted in water. Any acid diluted in water. Sulfuric acid, HCl, acetic acid, etc. Any of the acid is diluted in water to form dilute solution. Here, HCl plus water. HCl plus water to form H3O plus. H3O plus. H3O plus or H plus ions. Generally, H plus ions of HCl react with water, H plus plus H2O to form H3O plus. It's called a hydronium ion. Hydronium ion plus Cl minus ion. HCl react with water to form hydronium ion, H plus or H3O plus ions plus Cl minus ions. Suppose sulfuric acid, H2SO4. H2SO4 plus water. H2SO4 plus water. It will give H3O plus hydronium ion and SO4 2 minus sulfate ion, hydronium ion and sulfate ion. H plus. This H plus ion react with the water molecule to form hydronium ion, and SO4 2 minus ion is also formed. HBr. HBr react with the water. HBr is an acid. It react with the water to form H3O plus plus Br minus. Okay. Acetic acid. Acetic acid is CH3COOH. It react with water to form H3O plus. H3O plus plus CH3COO minus. CH3COO minus. Okay. Acid are the substance which produce H plus ions in water. Acid are the substance which produce H plus ions in water. All acids are the substance which produce H plus ions in water. Sulfuric acid, hydrochloric acid, check nitric acid. Nitric acid is HNO3 plus water. HNO3 react with water or diluted to water to form H3O plus hydronium ion plus NO3 minus. NO3 minus. Acid are the substance which produce H plus ions in water. H plus ions cannot exit alone and combine with water to form H3O plus. H3O plus is hydronium ion. Acids conduct electricity in solution due to the presence of ions. Acid conduct electricity. Why? Because of the presence of ions. HCl. HCl conduct electricity because HCl solution has H3O plus. H3O plus and Cl minus ion. H3O plus and Cl minus ion. Acids conduct electricity in solution due to the presence of ions. HCl has H plus ions and Cl minus ion. Nitric acid, HNO3 solution, dilute HNO3 solution has H plus or H3O plus and NO3 minus ions. So they conduct electricity. Movements of ions, it produce electricity. Next one, bases in water. We know that acid are the substance which dissolve in water to produce H plus ions. Acid are the substance which dissolve in water to produce H plus ions. And bases are the substance which dissolve in water. NaOH. NaOH is a base. It's dissolved in water to produce OH minus ions. Bases are the substance dissolved in water to produce OH minus ions. For example, NaOH. NaOH dissolved in water. NaOH dissolved in water to form Na plus and OH minus ion. Na plus and OH minus ion. Na plus and OH minus ion. And KOH. KOH dissolved in water to produce K plus and OH minus ion. K plus and OH minus ion. And magnesium hydroxide, milk of magnesia, is dissolved in water to produce Mg2 plus and OH minus ions. So, the bases are the substance dissolved in water to produce OH minus ions. Acid are the substance in water to produce H plus ions. Bases are the substance which dissolve water to produce OH minus ions. Okay, bases produce OH minus ion. Acids produce H plus ions. Acid produce H plus ions and bases produce OH minus ions in water. Acid conduct electricity and here also bases also conduct electricity in solution because of the presence of ions. KOH. KOH is a base dissolved in water to produce K plus and OH minus ion. So, bases conduct electricity in solution due to the presence of ions. And what is the difference between bases and alkalis? Bases are the substance to produce OH minus ions in water. But in alkalis are bases, the bases that are soluble in water. Soluble bases. Soluble in water. Bases that are soluble in water is known as alkalis. Bases that are soluble in water are called alkalis. Then alkali means bases that are soluble in water. The substances are known as alkalis. All bases do not dissolve in water. An alkali is a base that dissolve in water. They are soapy to touch, bitter and corrosive. Never taste or touch them as they may cause harm. Then the strength of an acid and base. Strength of an acid and base. The strength of an acid and base depends on the number of H plus ions and OH minus ion. If the number of H plus ion is high, that means that acid is a strong acid. Strong acid. Number of H plus ion is high, that means that acid is a strong acid. Number of H plus ion is low. Only few number of H plus ions are present. That means that acid is a weak acid. Acetic acid is a weak acid, but sulfuric acid, nitric acid, HCl, these are strong acids because the number of H plus ion present in that HCl, H2SO4, HNO3 are very high. But in the case of acetic acid, the number of H plus ion is very low. So, acetic acid is a weak acid. Okay. The strength of acid depends upon the number of H plus ions. The strength of acids depends upon the number of H plus ions. If the number of H plus ion is high, the acid is strong acid, and the number of H plus ion is low, that means the acid is a weak acid. And basic strength. Basic strength depends on number of OH minus ions. Basic strength depends on number of OH minus ions. If number of OH minus ion is high, that means that base is a strong base. Number of OH minus ion is high, the base is a strong base. If the number of OH minus ion is low, that means the base is a weak base. OH minus ion. The substance which produce OH minus ions, that is a base, and it produces H plus ions, that is an acid. And strength of acid and base, it depends upon number of H plus and OH minus ions. Number of H plus ion is very high, that means the acid is a very strong acid, and the number of H plus ion is very low, 1 or 2 is 2, that means the acid is a weak acid. And number of OH minus ion is very high, that means the base is a very strong base, and the OH minus ion is, number of OH minus ion is low, that means the base is a weak base. Next process is neutralization process. Neutralization. Neutralization means an acid and base combine to form salt and water. Acid and base combine to form salt and water. This process is called neutralization. Any acid, HX is an acid. It reacts with a base. Base is MOH because acid contain H plus ion and base contain OH minus ion. MOH indicate indicate base, HX indicate acid. It reacts to form a salt. Salt is MX. M is the cation and X is the anion. The salt is MX. And water, H2O, HOH, that is H2O. H plus and OH minus ion. This H plus from acid and OH minus ion from base combine to form water, H2O. For example, HCl. It's an acid. It reacts with the NaOH. NaOH is a base to form water. H plus and OH minus ion combine to form water. Water and remaining ions, Na plus and Cl minus ion. It's attracted to form NaCl, sodium chloride. Another example, H2SO4. H2SO4 react with the NaOH. To form water. And remaining ions are Na plus and SO4 2 minus. So the salt is Na2SO4. Na2SO4. Acid react with the base to form corresponding salt and water. General formula of acid is HX and base is MOH. Because acid are the substance produce H plus ions, base are the substance which produce OH minus ions. And they neutralize to form corresponding salt MX and water H2O. The process of dissolving an acid or base in water is highly exothermic. The process of dissolving an acid or base, acid dissolution or basic dissolution, acid dissolution, preparation of dilute HCl, HCl plus water, H plus H3O plus Cl minus. Preparation of dilute HCl solution, acid dissolution process. This process is highly exothermic. What is exothermic? Dissolution of acid or bases. The process is highly exothermic reaction. What is exothermic reaction? Yes, exothermic means it liberates heat energy. It liberates energy. During the reaction, it liberates heat energy. So, dissolution of acid or dissolution of base in that reaction, it liberates heat energy. Dissolution of an acid or dissolution of a base, NaOH dilution, NaOH. Preparation of NaOH solution. It's an exothermic reaction. Exothermic reaction. Na plus and OH minus ion. NaOH dissolved in water. Dissolution process of sodium hydroxide is an exothermic reaction. Exothermic. And dissolution process, acid dissolution process or acid dilution process, it's an exothermic reaction. That means it liberates energy. It liberates heat energy. If the substance liberates heat energy, that reaction is called exothermic. Then mixing of an acid or base with water result in decrease in concentration of ions per unit volume. Such a process is called dilution and the acid or base is said to be diluted. Mixing of an acid or base with water. Suppose NaOH. NaOH is mixed with water. Decrease in the water result in decrease in the concentration of ions. Suppose 100 ml water and 20 gram NaOH solution. And next 100 ml water. Next solution is 100 ml water and 80 gram sodium hydroxide solution. 20 gram sodium hydroxide dissolved in 100 ml water and 80 gram sodium hydroxide dissolved in 100 ml water. This one, second one is the concentrated solution because here 80 gram sodium hydroxide dissolved in 100 ml of water. Number of OH minus ion is higher. This is a concentrated solution. This one is a dilute solution. Here only 20 gram sodium hydroxide dissolved in water. Mixing of an acid or base with water result in decrease in the concentration of ions per unit volume. Such a process is called dilution and acid or base is said to be diluted. Then see these questions. Why do HCl, HNO3, etc. show acidic character in aqueous solution, while solution of compounds like alcohol and glucose do not show acidic character? Why? Because HCl and HNO3 in aqueous solution means it's dissolved in water. HCl and HNO3 dissolved in water, it produces H3O plus hydronium ion and corresponding anion Cl minus or NO3 minus. It produces hydronium ion H plus ions. HCl and HNO3 is dissolved in water, aqueous solution of HCl and HNO3, it produces H plus ions. H plus ion, the substance which produces H plus ions is called an acid. So HCl and HNO3 is an acidic substance. But in the case of alcohol and glucose, it do not show acidic character because it do not produce H plus ions in aqueous solution. Alcohol dissolve in water, it do not produce H plus ions. Or glucose dissolve in water, it do not produce H plus ions. So they do not show acidic character. But HCl and HNO3 dissolve in water to produce H plus ions. So they show acidic nature, acidic character. Next question. Why does an aqueous solution of an acid conduct electricity? Why does an aqueous solution of an acid? Aqueous solution of an acid. Aqueous solution of an acid means acid, any acid like HCl, H2SO4, HNO3, etc. Any acid dissolved in water. We know that HCl react with water or HCl dissolved in water to form hydronium ion and a Cl minus ion. The presence of ions. Aqueous solution, acid dissolved in water to produce ions, so it conducts electricity. Then why dry HCl gas not change the color of the dry litmus paper? Dry HCl gas not change the color of the dry litmus paper. Why? Yes, we know that acid are the substance which turns blue litmus paper to red. But here dry HCl gas is taken. Dry HCl gas. We also know that acid are the substance which produce H plus ions. But in the case of dry HCl ion, dry means absence of water. Dry HCl gas do not produce H plus ions. Dry HCl gas do not produce H plus ions. An aqueous solution of HCl produce H plus ion. Dry HCl gas does not produce H plus ion. Okay. Dry HCl gas does not produce H plus ion, but aqueous HCl, it produces H plus ion. Why does dry HCl gas not change the color of the dry litmus paper? Because dry HCl gas does not produce H plus ions. So, they does not change the color of the dry litmus paper. Okay, is it clear? Next question. While diluting an acid, why is it recommended that the acid should be added to water and not water to acid? For an acid dilution process, how to dilute acid? Acid is slowly added to water. Acid is slowly added to water. Not water is added to acid. No water added to acid. Why? Because acid dilution process or base dilution process is an exothermic reaction. It liberates high amount of heat energy. So, we recommended that for the acid dilution process, acid should be added to water. Acid should be added to water slowly with a constant stirring because it's an exothermic reaction. Next one, how is the concentration of hydronium ion affected when a solution of an acid is diluted? How is the concentration of hydronium ion, H plus ion or H3O plus ion affected when the solution of an acid is diluted? Concentration of hydronium ion decreases when it is diluted. Concentration of hydronium ion decreases when it diluted. Then last question, how is the concentration of hydroxide ion? How is the concentration of hydroxide ions affected when excess base is dissolved in a solution of sodium hydroxide? How is the concentration of hydroxide ion affected when excess base is dissolved in a solution of sodium hydroxide solution? Excess base is added, the concentration of OH minus ion increases. The concentration of OH minus ions increases. Okay. These are some important questions. Note it down. Then let's revise what we learned today before we end the class. Acids are the substance with sour taste and it changed blue litmus paper to red litmus paper. But base are the substance with bitter taste and it changed red litmus paper to blue litmus paper. And indicators. It showed different colors in acidic and basic solution. They are classified into three types: natural indicators, synthetic indicators, and olfactory indicators. Natural indicators are litmus, turmeric, colored flower petals, etc. Synthetic indicators are methyl orange and phenolphthalein. Methyl orange in acidic medium is red in color, basic medium is yellow in color. Phenolphthalein in acidic medium is colorless and in basic medium is pink in color. And olfactory indicators. Olfactory indicators mean substance whose smell changes when mixed with the acidic or basic solution. Note down, methyl orange color shade. In acidic medium, red color, basic medium, yellow color. Phenolphthalein, acidic medium, colorless, basic medium, pink in color. Then reaction with the metals. Reaction with the metals. Acid react with the metals. Acid react with the metals to form salt and hydrogen gas. And reactive metals react with the base to form hydrogen gas and salt. Next one, reaction with the metal carbonate and bicarbonate. Bicarbonate is also known as hydrogen carbonate. Hydrogen carbonate. Metal carbonate or bicarbonate. Acids react with the metal carbonates or bicarbonate to produce carbon dioxide gas. Acids react with the metal carbonates or bicarbonate to produce carbon dioxide gas. Carbon dioxide, water and corresponding salt. And carbon dioxide gas passes through lime water. The lime water turns milky because the formation of calcium carbonate. Calcium carbonate is insoluble in water. So lime water becomes milky. Then if excess of carbon dioxide is passes, the calcium carbonate and water react with the excess of carbon dioxide and to form calcium bicarbonate. It is soluble in water. Soluble in water. Then neutralization reaction. Acid and base react to form salt and water. Then reaction of metal oxide with acid. Metal oxide react with acid to form salt and water. Metal oxide react with acid to form salt and water. So metal oxides are basic in nature. Metal oxides are basic in nature. And non-metallic oxide. Non-metallic oxide react with the base to form salt and water. That means non-metallic oxides are acidic oxides. Non-metallic oxides are acidic oxides. Then acids react with water. Acid in water, it produces H plus ions or H3O plus ions. And base are the substance which produce OH minus ions in the OH minus ions. Acid produce H plus ions in water. As H plus ions cannot exit alone and combine with water to form H3O plus ion, hydronium ion. And acid conduct electricity in solution due to the presence of ions. H plus ions and corresponding anion. And bases are the substance dissolved in water to produce OH minus ions. OH minus ions. And bases produce OH minus ions in water. Bases conduct electricity in solution due to the presence of ion. KOH dissolved in water to form K plus and OH minus ions. Alkalis. Alkalis means bases that are soluble in water. Soluble in water are called bases. And strength of acid and bases depends upon the number of H plus and OH minus ion. If the number of H plus ion is high, the acid is strong, and the number of OH minus ion is high, the base is strong. The neutralization process, acid and base react to form salt and water. And acid dissolution process or base dissolution process is an exothermic reaction. Then how to dissolve acid or how to dilute acid? Yes, acid is slowly added to water because it is an exothermic reaction. In a pH scale, we can measure hydrogen ion concentration, hydrogen ion or hydronium ion. Hydronium ion is H3O plus. Hydrogen ion or hydronium ion concentration in a solution. pH range from 0 to 14. 0 to 14. If a solution having pH is equal to 7, that means that solution is a neutral solution. pH is equal to 0. pH is equal to 7. pH is equal to 7, the solution is neutral solution. pH scale range from 0 to 14. 0 to 14 and the pH value is equal to 7, that means the solution is a neutral solution. Then pH is less than 1. pH is less than 7, that means 0 to less than 7. 0 to less than 7, the solution is acidic in nature. If the pH of the solution is less than 7, 0, 0.1, 0.2, 1, 2 or 3.5, 4.6 etc. That solution is called acidic solution. If the pH of the solution is greater than 7, the solution is basic in nature. pH is greater than 7, 7 to 14, 7.1 to 14, the solution is basic in nature. pH is equal to 7, that means it's a neutral solution. pH less than 7, the solution is acidic, and pH is greater than 7, the solution is basic. The lower the pH value, that means less than 7. The lower the pH value, the higher the H plus ion concentration. pH value lower means H plus ion concentration high. H plus ion concentration high means the solution is acidic. Very good. The solution is acidic. pH value low, that means the H plus ion concentration is high. H plus ion concentration high means the solution is acidic, because acid, we know that in any substance dissolved in water to produce H plus ions, that substance is called acid. So the concentration of H plus ion is high, that means the solution is acidic solution. In concentration of H plus ion is high, the pH value become very low. Then the higher the pH value, if the pH value is very high or greater than 7, 14, 13, etc. pH value is very high, that means the concentration of H plus ion is very low. That is the concentration of OH minus ion is high. pH value is higher. pH value is higher means higher the concentration of OH minus ion. pH value is low means higher the concentration of H plus ion. pH value is higher, H plus ion concentration is very least or is equal to 0. In that condition, OH minus ion concentration is very high. Then universal indicator shows different colors at different pH value. Universal indicators show different colors at different pH value. Okay. Then this is a pH paper. 0 to pH reading from 0 to 14. pH is equal to 7. It's a neutral solution. Example, pure water and blood. pH of blood is nearly equal to 7.4. Then milk of magnesia. Milk of magnesia is magnesia hydroxide. The pH value of milk of magnesia is 10. That means milk of magnesia, basic or acidic? Yes, correct. Milk of magnesia. So, milk of magnesia is a basic solution. And sodium hydroxide solution. Sodium hydroxide. We know that sodium hydroxide is NaOH. Sodium hydroxide solution is about 14. That means sodium hydroxide is a base. And milk of magnesia and sodium hydroxide, which is strong base? Which one? Milk of magnesia or sodium hydroxide? Yes, very good. Sodium hydroxide is a strong base because the pH value higher means higher the concentration of OH minus ion. Higher the concentration of OH minus ions means that solution is a strong base. Then lemon juice. pH of lemon juice, it's nearly equal to 2.2. And pH of gastric juice, that is equal to 1.2. Lemon juice, the pH is equal to 2.2. That means lemon juice is acidic in nature because pH value of lemon juice is less than 7. It's acidic in nature. And also gastric juice. Gastric juice is also less than 7. pH value of gastric juice is also less than 7. So gastric juice is also acidic in nature. Then gastric juice or lemon juice, which is more acidic? Gastric juice or lemon juice, which is more acidic? Yes, gastric juice is more acidic than lemon juice because pH value low means higher the concentration. pH value low means higher the concentration of H plus ion. pH value is low means H plus ion concentration is very high. H plus ion concentration high means it's a acidic. Compare gastric juice and lemon juice. pH value is less in the case of gastric juice. That means more H plus ions present in gastric juice than lemon juice. So, gastric juice is more acidic than lemon juice. In the case of milk of magnesia and sodium hydroxide, both are bases because pH value is greater than 7. Here, milk of magnesia is weak base than sodium hydroxide because pH value is high means the concentration of OH minus ion is high. Concentration of OH minus ion is high means the solution is basic. Here pH value of milk of magnesia is only 10, but the pH value of sodium hydroxide is nearly equal to 14. So, OH minus pH value depends upon the number of OH H plus ions, or in the case of base, it's OH minus ion. OH minus ion concentration is high, pH value is high. OH minus ion concentration higher in the case of sodium hydroxide solution. So, sodium hydroxide is a strong base than milk of magnesia. But in the case of gastric juice and lemon juice, gastric juice is more acidic than lemon juice. Okay. pH value decreases, H plus ion concentration increases. H plus ion concentration increases, the solution is acidic. pH value increases, the OH minus ion concentration increases. Okay, is it clear? That is, pH is inversely proportional to H plus ion concentration and it's directly proportional to OH minus ion concentration. pH is high, OH minus ion concentration is high. pH is low, H plus ion concentration is high. And H plus ion concentration denote the acidic strength and OH minus ion concentration denote the basic strength. This is the pH paper. The value ranging from 0 to 14. Note this one, pH is equal to 7, the solution is neutral, and pH is less than 7, 0 to 6.9, the solution is acidic in nature, and pH is greater than 7, 7.1 to 14. The solution is basic in nature. Lower the value of pH, higher the concentration of H plus ion, and higher the value of pH, higher the concentration of OH minus ions. Okay, is it clear? Then importance of pH in everyday life. First one, human body functions within a narrow pH range 7 to 7.8. Then plants require specific pH range for healthy growth. Then soil pH affect plant growth and nutrient availability. Acid rain with pH less than 5.6, it's harmful to aquatic life, also harmful to human life. Then digestive system, stomach produce HCl for digestion. The pH is nearly equal to 1.5 to 2.5. Then tooth decay occur when pH in mouth is below 5.5. That means formation of an acidic condition. And last one, animals and plants use chemical secretion for self-defense. For example, bee sting, acids, nettle leaves, it secrete methanoic acid. Bee sting also secrete methanoic acid. Nettle leaves also secrete methanoic acid. Okay, note down. Bee sting and nettle leaves, it secrete methanoic acid for self-defense. Then this table is important. Mark it. Natural source, vinegar. Our vinagiri. Vinegar contain acetic acid. And orange or any citrus fruit like lemon, it's contain citric acid. And tamarind contain tartaric acid. Tomato contain oxalic acid. So these are acidic in nature. It turns blue litmus paper to yes, correct, red litmus. And then sour milk or curd, it contains lactic acid. Lemon contains citric acid. And sting, methanoic acid. Nettle sting, methanoic acid. Okay. Okay, is it clear? A blue color filter paper and red color filter paper dipped in curd. Observe the change. What do you observe? A blue color filter paper and red color filter paper dipped in curd. What do you observe? Yes, the blue color not filter paper, it's litmus paper. Blue color litmus paper and red color litmus paper dipped in curd. The blue colored litmus paper changed to red because curd containing lactic acid. Acid changed blue litmus paper to red. Okay. Similarly, orange, vinegar, tamarind, tomato, lemon, and sting, nettle sting, etc. And note the acids: vinegar or vinaigrette containing acetic acid, orange containing citric acid, tamarind, tartaric acid, tomato, oxalic acid, sour milk or curd, lactic acid, lemon, citric acid, and sting, methanoic acid, nettle sting, methanoic acid. Okay. Next one, salt. We know that salt are formed by the neutralization of acid and bases. Salt are formed by the neutralization of acids and bases. We know that HX, general formula of an acid is HX, and it's react with any base. General formula of a base is MOH to form MX. it's a salt and to form water. Mx is the corresponding salt and to form water. Suppose HCl. HCl react with HCl is an acid. It's react with the NaOH. NaOH is a base. NaOH is a base. To neutralize to form which salt? Na and Cl combine to form NaCl. So neutralize to form NaCl and H plus and OH minus ion combine to form H2O. And neutralization product of NaOH and HCl is NaCl. NaCl is a salt. Salt of HCl and NaOH. HCl is a strong acid, NaOH is a strong base. It's combined to form NaCl. NaCl is a salt. So, salt are formed by the neutralization of acids and bases. Salt having the same positive or negative radicals belong to a family. Salt having the same positive or negative radicals belong to a family. For example, NaCl and KCl. NaCl and KCl both are salts. It belongs to the family of chloride salt. It belongs to the family of chloride salt because NaCl and KCl having same Cl minus ions. Same Cl minus ion. So, it belongs to the family of chloride salt. Okay, is it clear? Suppose Na2SO4, sodium sulfate and K2SO4, potassium sulfate, sodium sulfate and potassium sulfate. These are two salts. It belongs to the family of which one? Yes, belong to the family of sulfate. Belong to the family of sulfate salt. Here SO4 2 minus ions, this salt and sodium sulfate and potassium sulfate having SO4 2 minus ion, same SO4 2 minus ion. So, it belongs to the family of SO4 2 minus ion salt, or sulfate salt. Salt having the same positive or negative radicals belonging to a family. Same positive or negative radical. Next one, write the chemical formula of salt given below. Potassium sulfate, sodium sulfate, calcium sulfate, magnesium sulfate, copper sulfate, sodium chloride, sodium nitrate, sodium carbonate and ammonium chloride. Write down potassium sulfate. Potassium K plus sulfate. Sulfate is SO4 2 minus ions. So the formula of potassium sulfate is K2SO4. Potassium. We know that potassium is K plus ion. Charge of potassium is plus 1 and charge of sulfate is 2 minus. Interchange the value. Here plus 1. Interchange the value. We will get the chemical formula K2SO4. Potassium sulfate is K2SO4. And sodium sulfate. Sodium ion is Na plus and sulfate. Sulfate is SO4 2 minus. Interchange the value 1 and 2. Interchange 1 and 2. So the formula of sodium sulfate is Na2SO4. Na2SO4. Next one, calcium sulfate. Calcium is Ca2 plus sulfate. Sulfate is SO4 2 minus. Here 2 is cancel out. So the formula of calcium sulfate is CaSO4. 2 is the common factor. So cancel it. The next one, magnesium sulfate. Magnesium is Mg2 plus. Sulfate is SO4 2 minus. Formula of magnesium sulfate is MgSO4. Then copper sulfate. Copper Cu2 plus. Sulfate SO4 2 minus. Common factor is 2, so cancel it. The formula is Cu, copper sulfate is CuSO4. Formula of copper sulfate is CuSO4. Then sodium chloride, sodium Na plus and chloride Cl minus. Sodium chloride NaCl. Sodium nitrate, sodium Na plus, nitrate NO3 minus. Sodium nitrate is NaNO3. And sodium carbonate. Sodium carbonate, sodium carbonate, sodium Na plus carbonate CO3 2 minus. Formula of sodium carbonate is Na2CO3, Na2CO3. And ammonium chloride, ammonium is NH4 plus. Ammonium is NH4 plus, ammonia is NH3. Okay. Ammonium is NH4 plus ion, ammonia is NH3. Here ammonium chloride, ammonium NH4 plus, chloride Cl minus. Formula of ammonium chloride is NH4Cl, ammonium chloride. Okay. Potassium sulfate K2SO4, sodium sulfate Na2SO4, calcium sulfate CaSO4, magnesium sulfate MgSO4, copper sulfate CuSO4, sodium chloride NaCl, sodium nitrate NaNO3, sodium carbonate Na2CO3 and ammonium chloride NH4Cl. Next one, pH of salt. pH of salt. Salt of strong acid and strong base. Strong acid and strong base. The pH of the salt of strong acid and strong base is neutral. That means pH value is equal to 7. For example, HCl, salt of HCl and NaOH. HCl is a strong acid, NaOH is a strong base. It's combined to form with salt. Combined to form, yes, NaCl. NaCl and water. H2O. That means NaCl is a salt of strong acid. NaCl is an example of salt of strong acid and strong base. The pH of NaCl solution is nearly equal to neutral. pH value is equal to 7. NaCl solution, it's a neutral solution. pH value is equal to 7. Then next one, salt of strong acid and weak base. Strong acid and weak base. Which one is strong? Yes, acid is strong. So the pH value of an acid is less than 7. Okay. Salt of strong acid and weak base. Strong acid and weak base. Here acid is strong. Acid power of acid is dominant than basic power. So the solution is acid. The salt is acidic in nature and the pH is less than 7. So salt is acidic in nature means pH of the salt is less than 7. Suppose for example, strong acid. HCl is a strong acid. It's combined with a weak base. Weak base is aluminium hydroxide. Aluminium hydroxide. AlOH3. It's a weak base. HCl is a strong acid. Aluminium hydroxide is a weak base. It's combined to form which salt? Aluminium and chlorine combine to form aluminium chloride. Formula of aluminium chloride is AlCl3 and H and OH combine to form H2O. This equation is not balanced. Okay. Aluminium chloride and H2O. Aluminium chloride is the salt of strong base, strong acid and a weak base. And the nature of aluminium chloride. Nature of aluminium chloride is acidic. pH value is less than 7. pH value is less than 7. Nature of aluminium chloride is acidic, or the pH value of aluminium chloride solution is less than 7. Why? Because Aluminium chloride is a salt of strong acid and a weak base. A salt of strong acid and a weak base is it's acidic in nature. The pH value is less than 7. Okay. Then last one, salt of strong base and weak acid. For example, NaOH. NaOH is a strong base and acetic acid. Acetic acid is a weak base. Acetic acid is CH3COOH. Acetic acid is a weak base. NaOH and acetic acid. It's combined to form a salt. Which salt? Sodium acetate, CH3COONA plus water. Sodium acetate is a salt of strong base and weak acid. So the pH value is greater than 7. pH value is greater than 7. The nature of this salt is basic in nature because this salt formed from sodium hydroxide and acetic acid. Strong base and weak acid combine to form sodium acetate. Strong base and weak acid. A salt of strong base and weak acid is basic in nature. Basic strength is dominant than acidic strength. Strong base and weak acid. It's basic in nature. So pH value is greater than 7. pH value is greater than 7. Okay, is it clear? Next topic, chemicals from common salt. Chemicals from common salt. Chemicals from common salt. First chemical is sodium hydroxide, NaOH. Sodium hydroxide, NaOH. Sodium hydroxide is produced by the chloralkali process through electrolysis of brine solution. Chloralkali process or electrolysis of brine. The process is also known as electrolysis of brine solution. Brine solution is sodium chloride solution. Brine solution, that is NaCl solution. Sodium chloride solution. Electrolysis of brine solution or electrolysis of sodium chloride solution. NaOH is produced by electrolysis of sodium chloride solution or brine solution. Sodium chloride solution is also known as brine solution. The process is called the chloralkali process because chlorine gas and alkali is formed. Here chlorine gas and alkali is formed. So the process is called chloralkali process. It's produced by the chloralkali process through electrolysis of brine solution. Electrolysis of brine solution. Electrolysis of brine solution. Brine solution is NaCl solution. NaCl solution. Here, when electrolysis means electricity is passed. When electricity is passed through an aqueous solution of sodium chloride. When electricity, it's a brine solution. When electricity is passed through an aqueous solution of brine solution. What is meant by aqueous solution of brine solution or aqueous solution of NaCl? That means NaCl dissolved in water. NaCl dissolved in water. Electricity is passed through an aqueous solution of sodium chloride. It decomposes to form. During electricity is passed through an aqueous solution of NaCl or brine solution. It decomposes to form NaOH, H2 and Cl2. NaOH, H2 and Cl2. NaCl plus H2O gives NaOH, Cl2 and H2. Electricity is passed through an aqueous solution of aqueous solution of brine solution. Aqueous solution means aqueous solution of brine solution means sodium chloride dissolved in water. Then electricity is passed. Sodium chloride is decomposed to form sodium hydroxide. Sodium hydroxide is an alkali and also form chlorine and hydrogen gas. Chlorine and hydrogen gas. The products sodium hydroxide, chlorine and hydrogen all are commercially important. Chlorine gas is given off at the anode. Anode, that means positive side of the battery. And hydrogen gas is at the cathode. Chlorine gas at the anode. Note down. Chlorine gas liberated at the anode and hydrogen gas at the cathode. And the remaining solution is sodium hydroxide. Sodium hydroxide. This is the brine solution, that is NaCl solution. NaCl and H2O. Brine solution containing NaCl and H2O. When electricity is passed, this cell is connected through anode and cathode. When electricity is passed, NaCl and water decompose to form NaCl containing Na plus and Cl minus ion, H2O containing H plus and OH minus ion. It's decomposed to form NaOH. NaOH solution. The remaining solution is NaOH. NaOH solution and H2 gas and Cl2 gas. H2 gas and Cl2 gas. Okay. Cl2 gas liberated at the side of anode. Cl2 liberated at anode. Charge of anode is positive. And H2 gas liberated at the cathode. Cathode means the electrode connected to negative terminal of the battery. Charge of cathode is negative. And some uses of Cl2 gas, chlorine gas is water treatment, swimming pools, PVC, disinfectant, CFC. CFC is chlorofluorocarbon, pesticides, etc. Some uses of hydrogen gas are fuels, margarine, ammonia for fertilizers. Manufacturing process of ammonia for fertilizers. Then brine solution. Brine solution is NaCl. It's decomposed to form NaOH. Uses of NaOH is degreasing metals, soaps and detergent, paper making, artificial fibers. Okay, NaCl, aqueous solution of NaCl decomposed in the presence of electricity to form NaOH, H2 and chlorine gas. H2 liberated at the side of cathode, Cl2 liberated at anode. The remaining solution is NaOH. Is it clear? Next step, first chemical is sodium hydroxide, NaOH solution produced by electrolysis of brine solution or chlor-alkali process, because chlorine and alkali is the product. Here sodium hydroxide is formed. It's an alkali. Next chemical is bleaching powder. CaOCl2. Bleaching powder. Chemical formula of bleaching powder is CaOCl2. Calcium hypochlorite. Bleaching powder produced by the action of chlorine on dry slaked lime. Slaked lime is calcium hydroxide. So, calcium hydroxide react with the chlorine to form CaOCl2. Bleaching powder, CaOCl2 plus water. Uses, we know that bleaching action, bleaching cotton, linen in textile industry, and bleaching wood pulp in paper factories as an oxidizing agent to disinfect drinking water. Bleaching cotton, linen in textile industry, bleaching wood pulp in paper factory as an oxidizing agent to disinfect drinking water. Next one is baking soda. Chemical formula of baking soda is NaHCO3. NaHCO3. Sodium bicarbonate. NaCO3 is sodium bicarbonate. Bicarbonate or hydrogen carbonate. Both are same. Sodium bicarbonate or sodium hydrogen carbonate. Chemical formula of baking soda is NaCO3. It's sodium bicarbonate or hydrogen carbonate. And sodium carbonate, the formula of sodium carbonate is Na2CO3. It's not baking soda. Baking soda is sodium bicarbonate, NaHCO3. And preparation of baking soda. NaCl, water, carbon dioxide and NH3. NaCl, water, carbon dioxide and ammonia. It's react to form ammonium chloride and sodium bicarbonate. What are the reactants? NaCl, sodium chloride. Sodium chloride, water, carbon dioxide and ammonia. Ammonia is NH3. It's react to form ammonium chloride and sodium bicarbonate. Ammonium chloride is the byproduct. Properties. It's mild non-corrosive base. It's mild non-corrosive base. That means sodium bicarbonate is a base. It's mild non-corrosive. Then the following reaction takes place when it is heated during cooking. We know that baking soda is used for cooking. For following reaction takes place when it is heated during cooking. Sodium bicarbonate, NaCO3, is heated. It's decomposed to form sodium carbonate. Sodium carbonate, Na2CO3. Sodium bicarbonate is heated to decompose to form sodium carbonate, water and carbon dioxide. Sodium carbonate, water and carbon dioxide. Sodium bicarbonate decomposed to form sodium carbonate, water and carbon dioxide. It decomposes in the presence of heat. That means it's a thermochemical decomposition reaction. It's an example of thermochemical decomposition reaction because it decomposes in the presence of heat. Any substance decomposes in the presence of heat, that reaction is known as thermochemical decomposition reaction. So the decomposition of sodium bicarbonate is an example of thermochemical decomposition reaction. Sodium bicarbonate decomposes in the presence of heat to form sodium carbonate, water and carbon dioxide. It liberates carbon dioxide gas. Uses making baking powder. Baking powder is a mixture of baking soda and tartaric acid. Baking soda, sodium bicarbonate. So baking powder is a mixture of sodium bicarbonate and tartaric acid. And used as an antacid. And in soda acid fire extinguishers. Next one, washing soda. Preparation of formula of washing soda is Na2CO3. Na2CO3.10H2O. Na2CO3, sodium carbonate. It's not an example of washing soda. Na2CO3 is not washing soda. Washing soda is Na2CO3.10H2O. Hydrated sodium carbonate. Hydrated sodium carbonate is washing soda. Hydrated sodium carbonate is washing soda. Formula of washing soda is Na2CO3.10H2O. Preparation. Recrystallization of sodium carbonate. Sodium carbonate react with the water molecule. Anhydrous sodium carbonate react with the water molecule to form Na2CO3 10H2. Anhydrous sodium carbonate react with the 10 water molecules to form Na2CO3.10H2O. Recrystallization of sodium carbonate. Uses in glass, soap and paper industries. It's used for manufacturing sodium compounds. It's used as a cleaning agent. It's used for removing permanent hardness of water. Permanent hardness of water. Then water crystallization. What is water crystallization? Fixed number of water molecules present in one formula unit of salt is water of crystallization. Fixed number of water molecules. Here washing soda formula of washing soda is Na2CO3.10H2O. That means washing soda contains 10 molecule of water. 10 water molecule present in washing soda. A fixed number of water molecules present in one formula unit of a salt. That means one salt containing a fixed number of water molecules. One washing soda containing 10 water molecules. One washing soda containing 10 water molecules. It's water of crystallization. For example, washing soda is Na2CO3.10H2O. Na2CO3.10H2O. One molecule of washing soda containing 10 water molecule. Another example, copper sulfate, hydrated copper sulfate. Formula of hydrated copper sulfate is CuSO4.5H2O. One molecule hydrated copper sulfate containing 5 H2O molecule. 5. It's a fixed number. Copper sulfate. Formula of copper sulfate is CuSO4.5H2O. And gypsum. Gypsum is CaSO4. Calcium sulfate. Copper sulfate is CuSO4. Gypsum is calcium sulfate. Hydrated calcium sulfate. CaSO4.2H2O. Gypsum is, formula of gypsum is CaSO4.2H2O. And formula of plaster of Paris is CaSO4.5H2O. CaSO4 calcium sulfate dot 2H2O. It's gypsum, but calcium sulfate plus half H2O. Half H2O. It's plaster of Paris. Number of water molecules change, the compound will change. Copper sulfate CuSO4.5H2O, gypsum CaSO4 plus 2H2O, plaster of Paris CaSO4 plus half H2O, baking soda Na2CO3.10H2O. Okay. And plaster of Paris. Plaster of Paris. Prepared by heating gypsum. We know that formula of gypsum is CaSO4.2H2O. Plaster of Paris. Formula of plaster of Paris is CaSO4.5H2O. Prepared by heating gypsum at 373 Kelvin. Plaster of Paris prepared by heating gypsum at 373 Kelvin. Gypsum CaSO4 calcium sulfate dot 2H2O. It's heated at 373 Kelvin to form plaster of Paris CaSO4 dot half H2O. CaSO4 dot half H2O. Okay. How to prepare plaster of Paris? Gypsum heated at 373 Kelvin to form. Gypsum decomposed to form or liberate water molecules to form plaster of Paris CaSO4 dot half H2O. Then plaster of Paris on mixing with water. We know that plaster of Paris is CaSO4 dot half H2O. Plaster of Paris on mixing with the water sets into a hard solid mass. That means plaster of Paris react with the water or mixing with the water. It's to form gypsum CaSO4.2H2O. It's a hard solid mass. It's a hard solid substance. Okay. Plaster of Paris is prepared by heating gypsum at 373 Kelvin and plaster of Paris on mixing with water to form gypsum. Okay, is it clear? Plaster of Paris is prepared by heating gypsum at 373 Kelvin to form plaster of Paris. Gypsum is heating at 273 Kelvin to form plaster of Paris, and plaster of Paris is react with water to form gypsum. Gypsum is a hard solid substance. And uses for making toys, decorative materials, etc. In hospital for setting fractured bonds, and for making smooth surfaces. Then do this problem. Five solutions A, B, C, D and E when tested with a universal indicator showed pH as 4, 1, 11, 7 and 9 respectively. Which solution is neutral? Which one is neutral? pH value of A is 4, pH value of B is 1, pH value of C is 11, pH value of D is 7 and pH value of E is 9. Which solution is neutral? Which solution is neutral? Yes, pH value is equal to 7. That's a neutral solution. So which one? Solution D. Solution D is a neutral solution. And which one is strongly alkaline? We know that pH is equal to 7. That means it's neutral. pH is less than 7. The solution is acidic. And pH is greater than 7. The solution is basic. Then we also know that pH value low means H plus ion concentration high. That means it's a strong acid. Strong acid. And pH value high means, the case of base, pH value high means OH minus ion concentration high and it's a strong base. Okay. Then which one is strongly alkaline? Strongly alkaline. Alkaline means strongly basic in nature. We know that in basic solution the pH value is greater than 7. pH in solution C, pH value of solution C is 11 and pH value of solution E is 9. Which one is strongly alkaline? pH value high. pH increases, OH minus ion increases and the basic strength increases. So strongly alkaline solution is solution correct C. And strongly acidic. Which solution is strongly acidic? If the pH value is less than 7, pH value is less than 7, the solution is acidic. Here, solution A and B. Solutions A and B. Both are acidic. Solution A and solution B. Both are acidic in nature. Which is strongly acidic? We know that pH value decreases, the H plus ion concentration increases, it's strong acid. Which pH value is low? B. Solution pH value of solution B is only 1. That means it containing more number of H plus ions. So it's strongly acidic in nature. Strongly acidic solution is solution B. And weakly acidic. Weakly acidic is solution A. And weakly alkaline is solution E. Okay. Arrange the pH in increasing order of hydrogen ion concentration. Increasing order of hydrogen ion concentration. Hydrogen ion concentration high means pH value low. Hydrogen ion concentration high means pH value low. So which one is the highest hydrogen ion concentration? It has low pH value. That means B. So the order is B greater than A greater than D greater than E greater than 11. C. Okay. Arrange the pH in increasing order of hydrogen ion concentration. Relationship between hydrogen ion concentration and pH. pH value is low means high hydrogen ion concentration. Arrange the pH in increasing order. This is the decreasing order. Increasing order is C, E, D, A, B. Okay. Increasing order. Hydrogen ion concentration high in B. This is decreasing order. Hydrogen ion concentration decreasing order. Here, arrange the pH in increasing order of hydrogen ion. So, C has the very least value, then E, then D, then A, and highest hydrogen ion concentration in solution B. Because pH value of B is 1. Okay, increasing or decreasing order. This one increasing order. This one decreasing order. Okay, is it clear? Then let's conclude. pH of a neutral solution, that is equal to 7. pH value is greater than 7, that means the solution is basic in nature, and pH value is less than 7, the solution is acidic in nature. pH value decreases, the H plus ion concentration increases, and pH value increases, the H plus ion OH minus ion concentration increases. Okay. Then some important chemicals. First one, sodium hydroxide. It's prepared from sodium brine solution, sodium chloride solution by electrolysis of brine solution or chloroalkali method. Then next one is bleaching powder. Formula is CaOCl2. CaOCl2. Clay line react with the chlorine to form bleaching powder. Then next chemical is baking soda, sodium bicarbonate. Baking soda is chemically sodium bicarbonate. And washing soda is hydrated sodium carbonate. Hydrated. It containing water molecule. How many water molecules? 10 water molecule. Na2CO3 dot 10 H2O. And this is very important. Note the formula of copper sulfate, gypsum, plaster of Paris, and washing soda. Copper sulfate CuSO4 dot 5H2O, gypsum CaSO4 dot 2H2O, plaster of Paris CaSO4 dot half H2O, and washing soda Na2CO3 dot 10H2O. Plaster of Paris. Preparation of plaster of Paris. Gypsum heated at 373 Kelvin to form plaster of Paris, and plaster of Paris react with water to form gypsum. Okay, thank you. See you on next class.